Hi everyone. Today I'm going to do a couple of absolute value exercise, just really easy mode warm-up exercise in order to get familiar with the properties of absolute value. And we're going to start with an easy one like x minus 1 absolute value less greater than 3. To solve this, we're going to use the property of less greater than, which is, as you can see, absolute value less greater than minus constant less greater than x less greater than positive constant. So what we want to do is to free up the x. In order to leave it by itself, to do that we have to add 1 to the equation in all terms. So that results in a plus 1 at the entire line. So we're going to have minus 3 plus 1 x minus 1 plus 1 less greater than 3 plus 1, which results in minus 2 less greater than x less greater than 4, which means that x is going to be contained between minus 2 and 4, and the solution is all x that belong in the interval minus 2, 4, parenthesis, because it's less great, so it's an open interval. For exercise 3b, we're going to do the other property of absolute value, the greater than. So here we have x plus 1 greater than 2. And the property of absolute value is that absolute value of x greater than a, meaning whatever representation you want to have, is going to equal to x greater than a union with x less greater than minus a. So in this case, as you can see, a is represented by the constant, in this case 2, and inside the absolute value, whatever it is that we have in the exercise, in this case, x plus 1. So what we're going to do is decompose the expression and write it down in the two separate means that we have, which is x plus 1 greater than 2 union with x less great than minus 2. Remember that the minus is going to be multiplying that constant on the right side of the equation. So as we saw before, we want to free up the x. And how do we do that? Well, we have to subtract minus 1 from the entire equation all across the board to keep consistency in the an equation. So it results in 2x plus 1 minus 1 greater than 2 minus 1 union with x plus 1 minus 1 less great than minus 2 minus 1. Okay, everyone following? Great. As you can see, we have subtracted minus 1 to the entire equation, so we cancel each other out in order to leave the x by itself, and we're going to end up with the following result: x greater than 1 union with x less great than minus 3, because minus 2 minus 1 is minus 3. And there you go. There's the solution. So what we're going to do now is draw the real numbers line. We have minus infinite on the left, plus infinite on the right, and we choose a couple of points there to represent minus 3 and 1, which are the critical points that we had in our solutions. As x is less great than 3, that means that any other number to the left of 3 is going to be part of the solution, not including 3. And as x is greater than 1, it means that every other number to the right of 1 is going to be part of the solution, not including 1. So that is a graphical representation, as you can see right here. And our analytical representation is going to be the interval of all the real numbers that belong to minus infinite, open interval, up to minus 3, open interval, because it's greater than, not equal, union with 1, open interval, 2 plus infinite. Remember, you never close down on an infinite interval. They're always open. And there you go. There is the analytical solution. Finally, our third warm-up exercise for the day. It's going to have a multiplier on the variable, but it's going to be pretty much within the same lines. So we're going to have 2 times x plus 1 less great than 1. What are we going to do to solve this? Well, we're going to use the same property of absolute value. In this case, the one that applies for less great than, which means absolute value less great than a, constant meaning representation of the right side of the equation, which is going to be equivalent to minus a less great than x less great than a. Remember, 1 is represented by a or vice versa, and whatever it is that you have inside the absolute value of this bar is going to be represented by the x. So in this case, we have minus 1 less great than 2x plus 1 less great than 1. And see how we copied exactly the property. So in this case, what we want to do, same as before, leave the x by itself. So how do we do that? Well, we simplify the equation, and as you can see, we have a positive 1 term there bothering the x. So what we have to do is subtract 1 again all across the board of the equation. So this adds up to minus 1 less great than 2x plus 1 minus 1 less great than 1 minus 1. And there you go. All we have to do now is solve, simplify the equation, and then we're going to move on in order to leave the x all by itself. Minus 1 equals minus 2. Then we have less great than 2x. And then we have less great than 0 because 1 minus 1 cancels each other out. And now we have the 2 bothering the x. So how do we get rid of it? Well, we have to multiply by 1/2 because when I leave that x by itself. 1/2 all across the board, and we're going to have minus 2 multiplying 1/2 less great than 2x multiplying by 1/2 less great than 0 multiplying by 1/2. So as you can see, we simplify the 2's at the side of the equation, and then we're going to leave the x all by itself. It's going to be very clean solution right there. Minus 2 simplifies minus 2, and then whatever we multiply by 0, it's going to be equal to 0. So let's use the right side of the board, and we're going to have minus 1 less great than x less great than 0. And there we go. There is the solution. All we have to do is represent it graphically and then analytically. Graphically, we have line of the real numbers, minus infinite, plus infinite to the right, minus infinite to the left. Pick a couple of spots. You're to represent minus 1 and 0, minus 1 to the left, 0 to the right. And as you can see, the x is trapped between those two values. So x is greater than minus 1, but less great than 0. So we highlight that. Values are not included because they're less great, it's not equal. And then the analytical solution, all x numbers in the interval of minus 1 to 0 open. There you go. That is the solution to all 3 warm-up problems. We're going to move out to a little bit more complicated problems in the next video in order to speed up the learning pace of absolute value and its properties.